If you've ever looked at the back of a cereal box or you've come across some fun facts about the human body, you may have seen data tables that look like this. Sometimes these values tell you what percentage of the total mass is taken up by a particular substance, such as this, or in other cases, you may see what percentage of your daily intake a particular food item is taking up, such as this. In both cases, though, what we're doing is we're expressing the amount of a certain substance as a percentage of something else. In chemistry, a common measurement we use is something called percentage composition by mass, where we express the percentage of one element or one grouping of elements as a percentage of the total. The way we do this is by plugging in the total mass of the element over the molecular mass or the formula mass of the compound or mixture or whatever it is times 100. For example, if you were asked to find the percentage of hydrogen in H2O, you'd first start by finding out the mass of the hydrogen in total. Now there's two hydrogens in H2O, so you go 2 times whatever its atomic mass is, which in this case is 1.008, over the total mass of H2O. And you can work that out by looking at the periodic table. That's 18.016. So 2 hydrogens and an oxygen gives you that. And then finally you multiply it by 100. When you work that out, you should get a mass of approximately 11.19%. If you repeated this process for oxygen, you should get percentage oxygen equals 16 over 18.016 times 100, and that should give you a percentage mass of about 88.81. Now you'll notice something. If you add the two percentages together, you get 100, and that's a good way to check that you've done percentage masses correctly. They should always add up to the 100. Now, if you want to do more practice on this, which I encourage you to do, it's on page 65 of your activity books. Please do as many of those as you can. Now, in some cases, you'll be given data of percentage composition by mass, and you'll have to use that to work out the formula of a substance, basically going in the reverse direction of what we just did. It's important to note, though, that when you work out the formula, you will get one of two formulas. It'll either be the empirical formula or the molecular formula. And before we actually learn how to go from percentage mass to these formulas, we have to learn the difference between these two types of formulas. The difference between the two is what it actually communicates to you. A molecular formula tells you exactly what is in a molecule, exactly what elements and how many of each. So an example of this is C6H12O6. It tells you that this molecule, whatever it is, has 6 carbons, 12 hydrogens, and 6 oxygens. On the flip side, an empirical formula tells you the elements present, but it tells you the ratio of atoms in its simplest form. It reduces those ratios to its simplest form, either for convenience of calculation or some other reason. So for example, for C6H12O6, you can divide all those numbers by 6 and reduce that to its simplest formula, which is CH2O. Both of these have a role in chemistry, but in this case we're going to be using both. Sometimes the empirical formula and a molecular formula of a substance are exactly the same. An example of this is CO2. CO2, its empirical formula tells you you've got 1 carbon to every 2 oxygens, but if you look at its molecular formula, the formula will be the same. 1 carbon and 2 oxygens, that's what's in the entire molecule. So here we have some examples to do, to go from molecular to empirical and vice versa. So the first example, H2S, if that's its molecular formula, its empirical formula can't be reduced any further, so it would be exactly the same. Question 2, however, if its molecular formula is C2H4, you can reduce that further by dividing it by 2. Its empirical formula, therefore, will be CH2. Question 3 has NO2. Now, with that empirical formula, your molecular formula could be a range of things. It could be NO2, it could be N2O4, it could be N3O6, and so on and so forth. As you can see, the options are limitless. So we normally, when we go from empirical to molecular, we need a little bit more data. Often we need the molecular mass. And if we have that, we can actually make the link. Okay, so here we have a question now to find empirical formula. Normally when you're given percentage composition by mass and you're trying to find formula, the first thing you can find is empirical formula. and that's what we're going to do for this question. We've got a substance, it's 72% chlorine, 24% carbon, and 4% hydrogen by mass. We're going to try and find empirical formula. Step 1 to this is to actually set yourself up. And to do that, what you do is you're going to assume that you've got a 100-gram sample. You've got 100%, so 100 grams, easy link. That way, what we can do is we can pretend we've got 24 in this case, grams of carbon, and then 4 grams of hydrogen, and then 72 grams of chlorine. I've set it up in this order, carbon, hydrogen, chlorine, because that's normally the way it's written, but it doesn't really matter in this case. It will matter later on in other years to come. Next thing you want to do is divide each of those elements, or each of those masses, by their relative atomic mass. And in this case, so carbon, you divide it by 12.01, hydrogen divided by 1.008, and then chlorine is divided by 35.45. When you do this, you should get answers of 1.998 for carbon, 3.97 for hydrogen, and 2.03 for chlorine. Then that brings us to step 3. In step 3, what we're going to do is we're going to convert this to whole numbers, and the most common way to convert this to whole numbers is to divide all of these three numbers by the lowest number in the series. When you do this, the lowest number is 1.998. So if you divide all three of them by 1.998, you should get numbers that are 1, 2, and roughly 1 there as well. You can round within reason. So if it's within 0.01 or 02, you can round off, but that should give you this as your numbers. Basically, that tells you your empirical formula is CH2Cl. So part 2 of a typical question of this would look like this. It would say find molecular formula of CH2Cl if its relative molecular mass or its molar mass is 148.431. And the way you do this is you find, first of all, mass of one empirical unit. In other words, you find the mass of the empirical formula. And to do that, you go ahead and add the carbon, the hydrogen, and the chlorine. So 12.01, 1 carbon, plus 2 times 1.008 plus 35.45. And this should give you 49.476. The next thing you do is you find out the number of empirical units. You find out how many of these you need to get up to that mass. We know how many one of these weighs. We now need to know how many of them we need to get up to that number. So we find the number of empirical units. The way we do that in this case is we do 148.431 over 49.476, and that should give you roughly 3. So now that we know we need 3 lots of those empirical units or empirical formulas to make the full thing, the full molecular formula, we can take that and multiply it by 3. And if we multiply it by 3, we should get C3H6Cl3. And so we're left with this as our empirical formulas and our molecular formulas. So to do more practice on this, please go to page 62, 63, and 64 of your activity books. Do as much practice as you can, and also do the prac on empirical formulas that is in your prac books. Thanks for listening.